to my session today about GraphQL explained through performance testing. So I'll be doing some live coding later on as well, so it might be fun. So make sure to watch while I'm doing this, because sometimes I need some help debugging things. But I guess we'll be doing all right. So who's this talk for? We're at a front-end focused conference, but it can also be interesting if you're working on the back-end side of things, or maybe if you're a tester and you're trying to figure out if the team that's adopting GraphQL will need your help in testing it, or if it's actually useful in testing it. And maybe even, this is something I didn't realize before, but I gave this talk once before in India, and the audience were mostly working with REST APIs, and they even learned how to use performance testing for REST APIs. So even if you're not interested in GraphQL, or it turns out not to be the right technology for you, there's still something you can take away from this session. Some reasons for choosing GraphQL might be performance, or maybe some reasons to leave REST APIs behind could also be performance. So I'll be sharing some insights on the performance part as well. GraphQL isn't only about performance or having a type system, it's about much more. I'll briefly touch on those topics, but if you want to learn how you can leverage GraphQL for your entire company, you probably need to look me up on YouTube or Twitter and find out there. So today we'll be mostly focused on the sort of performance developer experience part of GraphQL. So my name is Roy. I'm from the Netherlands, actually. If you're from the Netherlands as well, I come from a small village close to Eindhoven. Currently living in Amsterdam and doing all sorts of things. I used to work at a startup called StepZen. We help people build GraphQL APIs. So I'll be using a StepZen GraphQL API today. But I'm not going to explain you how to build one. You can look it up on the internet. But we are going to use a GraphQL API that I already made. I also write programming books. If you're into React or maybe GraphQL after this talk, you can also find my books and videos online. So what do you already know about GraphQL? Is someone using GraphQL already? Okay, few, that's good. Is there someone that hasn't heard about GraphQL? So you all heard about GraphQL, so that's good. Oh, one. That's nice. So I'm going to do all the explanations just for you now. No, it should be all right. I'm briefly going to handle GraphQL again, just to make sure that we're all at the same level and we have some idea of what to expect. So GraphQL is what we call a query language for APIs. My first query language I ever used, I think, was SQL. So I'd like to say GraphQL is like a version of SQL, but then for APIs, when applied correctly. It's very declarative, much like SQL, where you would write a statement. You would select some fields that you like to retrieve. You define which databases, tables it should get the data from. In GraphQL, it's pretty similar. So I'd like to say it's a query language, but then for APIs, because GraphQL isn't tied to a database, it isn't tied to a REST API, it isn't tied to a graph database. I think that's a common misconception, that GraphQL only works for graph databases. It works for all your data sources, and the way we see people using GraphQL today is mostly to abstract away all the different backends. So it's a query language to work with APIs. It looks a bit like what you're seeing here. So you would define the operation. In this case, it is a query. There are three operation types in GraphQL. You have queries for read-only data. So if you're working with REST, it's a bit like a GET request. We have mutations, which are to mutate data. So it's a bit like post, put, patch, and delete. You can basically mutate data on every single way through a single operation, which is kind of neat, because I still don't know the difference between put and patch in REST. Maybe I should know, or maybe everyone keeps implementing it wrongly. At least I see people using it both. So in GraphQL, there's just one way to mutate data, which is mutation. And then there's also subscriptions, which is someone using subscriptions? No? Yeah, it isn't used that much. I think also because the GraphQL technologies around subscriptions are a bit behind from what you can do today with other protocols such as events and messages. But it's a way to get real-time data. So you could subscribe to an information stream, and then you would get updated information. But usually it works over WebSockets. I'm not a real fan of WebSockets, and I think most people that work with real-time data aren't really a fan of it. So that's probably why it's still a bit behind in adoption. A GraphQL query, again, will look like this. So we learned about the operation. You would define the fields you'd like to retrieve. The name of the operation, which is getup_user, is actually also a field if you would dive into the specification, but you would define fields, and fields can be nested as well. It doesn't mean that there is like a relational type or it's like really nested data. It could also be the way your schema is designed. But you can just define relationships like this, and you can also use parameters, both at the top level, which will be sort of line number 2, but also somewhere in between if you'd like to restrict the number of followers returned. And then what I really like about GraphQL APIs is that the response will always be similar to your request. So the main thing I hate about REST APIs is that usually documentation is behind, and you've no clue what information you receive until you actually send a request. So with GraphQL, you already know if I'm asking for these fields, I will get JSON, and it will have more or less this structure. With a REST API, you'd send a request, and you expect to get some JSON back. Usually you get data back, but you don't really know which fields will be present or what the relationships between the data types are. So with GraphQL, you formulate your request, and you'll get the exact same format as in your request. So it's a bit like the Spice Girls song. You just ask GraphQL what you really want, and then you'll get just that information stream back. So it's good to know that you already know what your response will look like before you even send the request. And this will be useful later on when we do the testing as well. So another thing which I really like is you have a single endpoint for all your resources, meaning that you don't have this sort of nested tree of all these different endpoints that you need to tie together in your front ends. You just have a single endpoint, and based on your request, you can retrieve data from all these different sources. It could be an entity from your database, it could be a REST API, it could be even maybe types from the Graph database if you decide to use GraphQL with a Graph database. And especially when we look at the testing, you can see this is really important. In here, you can define such as nested relationships like this. So what I've done, I actually created a GraphQL version of the Twitter REST API. And this was before the Twitter REST API was really expensive. I think today you pay a couple of $1,000s even to get access to the API in some sort of production way. So what I've done here, I took the Twitter REST APIs to find tweets based on a keyword. In this example, based on the keyword Einstein. And whenever you send a request to this REST API, it will return a list of tweets containing your keyword, but it doesn't contain the name of the person that tweeted this. Instead, you get a reference to a user ID or some other sort of identifier, and you need to send a second request in order to figure out what the name of the author of the tweet is. So I created this GraphQL API based on this REST API, and I was able to bring both of these responses together into a single response. And this is something I really like about GraphQL. You can create relationships between your data, even though the relationship isn't defined as it would be defined in a database or in a Graph database. Even if it's a REST API, you can still make these combinations. Of course, it will take some work whenever you build your GraphQL API to bring these things together. But the good thing is you only need to do it once. So if you have multiple people using this API, you're actually solving the problems of all these people instead of just solving it once in your own application. So you can define these nested relationships. Doesn't matter where the data is coming from. And then also what I really liked, and what you probably also like as you're at a front-end focused conference, is that GraphQL is based on a type system. Is someone here using TypeScript? Oh, nice. Most of you are. So the cool thing about GraphQL is that as it has a type system, you're able to generate types based on that type system. So you don't have to manually do this. For REST APIs, you maybe create these types somewhere in your front-end code, or maybe you're sharing types between your backend and your front-end, which would be really great. There's also something called TRPC, which is quite a cool technology if you're building a full-stack application. I've done some other talks around why GraphQL is more than a type system. So I've read on Twitter that people choose to go with GraphQL because it had a type system, and they made a decision a couple of years ago, and now they revisited this decision because you can also use gRPC. So if your only reason to use GraphQL would be a type system, then you're missing out on a lot of other things. So it's good to know it has a type system, but it's doing way more. The things I mentioned above, but also if you would scale GraphQL across maybe a department or a set of teams, your entire company, there's much more value you could get from it than just the type system. But it's good to know it has a type system. It's very useful if you're working with TypeScript, or maybe even if you're working on integrating a GraphQL API in any sort of backend that's based on a programming language that is strongly typed, you can make use of this type system. It will look a bit like this. Well, this is a visualized version actually, but every GraphQL API will come with a GraphQL schema. And in the schema, you can find type definitions for all the fields, both sort of on field level, but also if you have your list of operations, such as queries, there will be return types to find there as well. So you can be sure whenever you send a request to a GraphQL API that the data you will get back is coherent with the type system. So in a lot of different tools that you can use when you're working with GraphQL, you will find a playground like this. And in there, usually there's a tab that says docs or documentation. And in there, you would be able to get a visual representation of the type system. This will also work in Postman, by the way. I think they added it like a year ago. So if you have a GraphQL API and you don't want to use the sort of built-in playgrounds that all the different tools have, you can also just put your endpoint in Postman, and it will be able to look at your schema and then help you to do auto-completion and figure out more of things from the schema. So what I like to say about GraphQL is like a query language for APIs. We learned all these cool things it's doing. In short, you can say it gives you control over the data from a client perspective. So if you're integrating with a GraphQL API from your front-end client, you have control over the data that you receive. Of course, there could be limitations in the GraphQL schema, because if the data isn't there or the relationship isn't there, you won't be able to create this relationship in your front end. It should be done on the back end. But whatever your back end makes available to you, you're able to customize and bring together in the way that makes sense for you. So you get control over the fields that are returned, or certain relationships will be returned, yes or no. And most of all, I'd say it improves the developer experience, not only from all the cool tools that are built around it, but also because you get auto-completion whenever you send a request through these playgrounds or even through Postman. You don't have to deal with bringing all these different REST APIs together, maybe in your state management or maybe somewhere else. So developer experience is a huge thing for me. I love to write code, but I hate it when the developer experience is shitty, or you need to take all these different steps to figure out how things work. So it's good to see that the developer experience is really beneficial. And of course, the type system. But like I said, type systems are not the main reason to use GraphQL. So let's have a look at how GraphQL works. So I've put together a small demo. So I deployed a GraphQL API already, so I don't have to worry about that part. And I'm also using K6, which is a open source JavaScript tool for load testing. They don't really like the word load testing anymore. So I worked together with K6 on writing an article around GraphQL performance testing, and actually mentioned they prefer performance testing. I'm not sure why. Maybe if one of you is a tester, you can explain me why load testing would be a bad term to use. But I'm not a tester, so that maybe also makes sense. So I'm using K6. It's pretty cool. You can install it from npm, and it's just a JavaScript package that you can run from your terminal. But of course, you could also add it to your CI/CD. There's other performance testing tools that I used in the past, but K6 somehow seems to be the easiest one to use. I believe it's also being maintained by Grafana, so they do a pretty good job in making sure that this whole library sticks. So what I've done for today's thing, I took a REST API. I actually took a different one, but it doesn't matter. I changed my demo, I think. So I took a REST API, it says practical dev, but I actually took the JSON placeholder REST API. I believe practical dev changed their rate limit, so it made it kind of hard for me to do load testing. So that's why I changed it. I then turned the REST API into a GraphQL API using the StepSend engine, and in the end I would get a GraphQL API. So what we'll be using is the GraphQL API. And I've took a couple of REST endpoints, and I transformed those into GraphQL queries. So a query to get a list of posts, and a query to get a single post. And what I also done, I took a third REST endpoint to get the user that wrote each of these posts, and I made a relationship with the other queries. So in order to load test this, I have some code here. But let me actually show you the GraphQL API first. So I have two queries I'm going to be testing. So I have one query to get a single post. So I can use this query to get a post, maybe with ID 1, and I maybe get the title. So this is something I would do with GraphQL, right? I want to get a specific post, and I only want the title, so I'm going to be using the title field in here, and the only result I get will be the title. But if you're working with a REST API, you don't really have a choice, and you're sort of forced to take all these fields that are available like this. Meaning you'll have way more data going back and forth between your backend and your front end. And in the first sort of test I'm going to write with K6, so I actually wrote it already, but I'm just going to make some changes there. I'm going to show you the difference in load you can expect if you have this sort of setup, where you have a REST API, but you're just passing too much information to your front end. So I've created this test here, which is testing a single query. And so what I've done, we're going to load test this GraphQL query, but you have to imagine this GraphQL query. Is this large enough, by the way? So this GraphQL query represents a REST API. So it wouldn't be fair for me to load test a REST API and then load test a GraphQL API if they are built with different technologies, because they are deployed somewhere else, and I wouldn't know how fast one server is, or if there is a cold start in the other one. So I GraphQLize these REST APIs, and I'm going to take this query, which is called getPost, with all these fields, which are the same fields my REST API would return, and I'm just going to run a small performance test and see what it will do. So this would be something like API/posts, and then /1, because I'm going to retrieve a post with ID 1. Or actually, let me just retrieve all the posts. Can I do that? Let me see if it has the same return type. Otherwise, it will look weird. So I have my list of queries here. I have getPost and getPost. So they should have the same return type. So it should be good. So I'm going to use this load test to get all the posts I have, which is similar to this REST API endpoint. And I'm just going to run it like this, so I have all the fields, and it will return all the data that my REST API would return. I've set up K6, so I'm just importing their HTTP wrapper. I have a query here, and I need to provide an endpoint, so this would be my GraphQL API. I would be passing my query, and then I would be passing the headers as well, because in GraphQL, everything is JSON in your response, so I need to make sure that I set the content type as well. So the only thing I need to run this is use the K6 CLI. So what you do when you install K6, you install it as a global dependency. So you basically do, so to install K6, you can run this, and then GitHub Copilot is helping me, but it's giving me the wrong result. You do npm install with the global flag, and you would install K6. And it's the only thing you need. You don't need to set up an account or whatsoever. If you actually will be performance testing on your own server, you can take their Docker, those kind of stuff. And of course, as they need to make money as well, they have a cloud dashboard in case you want to get insights in all your performance tests. But you don't need it for this tutorial, or this demo actually. So I'm going to be load testing this endpoint with this query. So when I run this, I can run it for 30 seconds, but maybe I'll run shorter ones later, just to make sure that I don't overspend my time. So it's running the test now. So what it's doing, I am executing this script. It's basically one scenario. You can have multiple testing scenarios in one script. I'm going to use 10 virtual concurrent users over 30 seconds. So what K6 is doing, it's taking these 30 seconds. It takes 10 virtual users, and then it's going to try and execute as many requests as it can. So if we look here, let me scroll down first. So this is our completed test. So K6 was able to do almost 2,000 iterations. So it was able to send 2,000 requests to this endpoint. And we're mimicking the REST API endpoint now because we have the query with all the fields. Working with 10 concurrent users, so you can assume there will be 10 people sending this request over a time frame of 30 seconds. So 2,000 requests. I don't really care about the loading times at this moment because I'm running this from my computer. I'm connecting to the Wi-Fi of the venue, so it doesn't make sense to sort of debug the performance and see if it could be improved. I'm mostly checking how much data I received because performance is something that's really hard to grasp and it depends on too many factors. So I can see, I'm not going to look at data sent as well, because if I would send a request to a GraphQL, to a REST API, I'm not sending any data at all, besides maybe some headers. I'm only going to look at this one. It shows that if I have 10 people doing 2,000 requests in total, I'm almost sending across like 2.5 megabytes, or a bit more actually. So it's a lot of data going back and forth. Well, maybe if I would look at my query, I would only need a really small percentage of this data because I'm retrieving ID, name, all these sort of things that maybe I don't need. So what I'm going to do next, I'm actually going to get rid of all the fields I don't want. So maybe I don't want to get the address. So what is the address here? I think it's the wrong query, actually. Let me go here and take this one. Does this one work? Yeah, this is better. So let me rerun this one. So I'm going to get posts with all these fields. And as it's a REST API, I can probably get even more fields. Let me see these ones. And then I have comments as well. I have ID, I have email, I maybe have a body. Okay, so let's assume this is a REST API. So circle back. Keep everything you just heard at the top of your mind. Going to copy this, and then I'm just going to rerun my test for 10 seconds. So we have our actual query, because probably this is just running against some error because we have wrong fields in there. So let me run this for 10 seconds. It's a bit short maybe for a performance test, but it should be good. It should show the sort of overall idea. So again, it's going to send as many requests as it can. But this time you would have the correct query. There's way less requests, so let me do 30 seconds again, actually. It's a good way to fill time if you have 45 minutes to speak. It's also the right time if someone has a nice joke we can use. So I'm rerunning this, sorry for using the wrong fields. So the thing is, K6 doesn't really handle errors unless there are any HTTP errors. And if you've been using GraphQL, you probably know that even though there might be errors, you still get a HTTP 200 status code, which is good because you don't want your code to break. But it's also bad in situations like this where I'm not sure what's going on. So you can see I was able to do way less iterations now. And I think this is closer to what I was expecting. And also the data received is way bigger because now I'm actually getting fields back. Because now I'm actually executing this query as much as I can. And in the previous time, I was sending wrong fields, so I probably just get a really small response saying there's an error. So I hope that didn't confuse you too much. So we were able to do 700 requests, so that's the sort of starting point. And we transferred 122 megabytes of data, which is a lot for a simple request like this, where you would get a list of posts. So imagine you're using the REST API version of this endpoint, maybe on your home page. It would be really slow. You probably have caching, but still. If you would go to a category page or some sort of page where you would be retrieving all this data, but you only need a small subset. So with GraphQL, you probably decide to only take a couple of fields. Let's suppose we don't want to show the user. We maybe want to show, also don't want to show comments. We just want to show the ID, body, and title of all our posts. We just have these fields. If I would take this query, and let me write down the 122 megabytes somewhere. I think if I do this, it goes down. So when we did our first test, so for the REST-like test, which is this one, we would have 733 iterations. And I should comment this out. And we had 122 megabytes. Like this. So now if I'm going to change my test, and I keep title, body, and ID, and I'm going to get rid of all these different things. If I would save this, I'm expecting to probably do more iterations, right? Because there's less data going back and forth. But I also expect to get less data received, because I'm only requesting a subset of my data instead of all the data. So let me rerun this test to show you if we're doing better. So again, I'm going for 30 seconds because it's a better time frame than just 10. I'm using 10 virtual concurrent users. You can use more actually if you want. So if you look at my request here, I'm defining the number of virtual users I have. I'm defining the duration. There's more parameters you can set in case there's other things you feel are important. And also, these are just really basic performance tests. There's much more you can do just by setting up this thing. So my request is finished. You can see we almost halved, or maybe a third, of a request now, because we have 46 megabytes compared to the 122 that we had before. And we were able to do more requests because there's less data being received. We're also able to send a second request faster. So in here you can see that if you would be using GraphQL for this specific use case, so instead of using a REST API to get a list of all your posts and then all the metadata attached to it, with GraphQL you can select only the fields you want. So you're able to not only transfer less data, you're also able to do more iterations, meaning it will be faster presented to the user. So this is just a really simple use case because we're taking one REST API, and we see the difference here for GraphQL test. We would have like 1700 something, oh, not 1000, and like 45 megabytes, like this. So it's a huge improvement already, but there's more we can do. The most interesting part, I'd say, would be to do like a multi-query one. And for this, I think as the other one is broken, I'm just going to get the posts from here. So you can see we have a way to get a list of posts. And there's a user attached to it. But let's assume there would be no user attached to it. And you would need to send another request to get the user for your thing. So let us take a single post. I'm going to get post with ID 1. And here GraphQL's type system is kicking in. This should be a string, like this, or no? Oh yeah, that's good, smart, thank you. So let's suppose I'm going to get a post, I'm going to get a couple of fields for it. And then I'm also going to get the user ID. And let's just assume that the way I've set it up, I wouldn't be able to get the user information embedded into this query. So I would need to send a second request in order to get the user. So if I would be going for get user, I can send a second request that says get user. I need to define the ID of the user, which is also 1, a bit boring, but it's okay. And then I'll probably have all these fields. So I want to get the address for the user, which could be like a street, a city, much more you can put down here. I maybe also want to get the name of the user, or the username. So you can see where we're heading. If you would have a REST API, you would have, I don't know, /post/ your ID. And then based on the results from the REST API, you would have to do /user/ID. For some REST APIs, you might also be able to do /post/ID/user. This sometimes works. Really depends how your REST APIs are set up. So with a REST API, I'm sort of forced to do my requests like this. So I need to do them one by one. I'm not even able to do this in one request. I need to send 2 different requests. So now I'm still doing it more or less in one request. So I need to do this one first, and then I would have to write a second query. Let me just call this my second query. These names are a bit lame, but it's okay. Just doing a demo. Second query like this. So I first do one request, and then I do the second request. So this is what you would do if you would be using REST. So let me try and test this use case. I'm going to copy this one. Going back to my code, and as you see, I already set up the frameworks. So this one we can also delete. And I'm going to take the second query to get my user information. Like this. I didn't format it nicely, and there's also way more fields I can retrieve. If I go back to my single query, like this, you can see I can take all these fields and also add them to posts, because a REST API, I would get all the fields all the time. And I'm not going to get this user. And then for my user API, I'm able to get way more fields as well. But I guess you already get the trick. The more fields we add, the more data. So a REST API would always return way more data. So this is setting up to work with 2 queries. There's sort of 2 ways in case 6 to handle group requests. I'm cheating a bit because I'm going to use a batch function here. So I'm going to send these requests in batch, because I'm assuming if you're working with a REST API and you sort of have to tie all these data entities together, you're doing some sort of batching, at least to speed up your performance a bit. But more usually, you maybe use a group in case 6 like this. I'm sending 2 requests. I'm sending one request to my one endpoint, so this will be to get the posts, and then another one to get the users. I see I have some variables in here. Let me get rid of those. I think I did a demo like this then before. I used a different GraphQL API, and I tried to be smart and put random values in there. But then some of these values didn't exist and didn't broke my test, but it broke my results. So let me save this. I have 2 queries, post and user, and I'm going to assume these are REST APIs. I'm going to test them by sending, in every iteration in my test, I'll be sending 2 requests. So I'm going to clear my terminal here. I'm going to rerun this test, but now I'm going to use the multi-query. Let's say this is multi-query. When I press run, we're going in for another 30 seconds of testing with 10 virtual users. We're just using a different script this time. And we're simulating a REST API where we need to get the information for the user in the post in separate requests.
Are they in order every time?
They're batched. So they're not really in order. They're just sent at the same moment. So it's not an ideal test to mimic it, but it's the best I can do without spending a lot of time writing some clever script. So if we're looking here, we can see data received is really small, which is interesting because we defined quite a lot of fields. We're doing 1867 iterations. So these iterations are double of this. So these are the number of requests we do. We send 3,700 requests, but we're batching these. So we're sending, if I go here, we're sending 2 requests in every iteration. So this number would be double the number of this one. I don't get as much data back as I expect it to be, so that's interesting, but maybe we can debug that later. And as you can see, we're going to, let me just store this number. So this will be the total number of iterations we will be able to do. So this would be this number. So this is the rest-like iterations, will be this number. So what I'm going to do next, I'm going to get the user automatically. So if we were looking at our single query thing, we already noticed it was possible to get the user with the ID and the name like this. So if I save this, I'm just going to rerun this script because it's doing a single query, but in here I have the nested relationship. As opposed to REST, I can do it all from a single request. So I'm going to phrase it like this. I'm going to get all the posts, or actually I'm going to get a single post, otherwise the results will be weird. Let me just into one. So let's just assume you wrote a viral post on Hacker News or maybe on some other channel, and everyone is trying to load the post with this ID. I'm going to save this, and then I'm going to rerun this test, but then I go for the single query. So I'm expecting it to do more requests, but you never know. Because now in every iteration there will be just one request instead of two. So we should be able to do more. And I'm also expecting a bit less data to be transferred. But I also got the idea that something is going wrong in my previous request because I only transferred 4 megabytes. And before we transferred like 122. But it's okay. Let's see what's happening. We're actually able to do less requests, or about the same number. So I think something is wrong in my my testing case here. Let me see. We're also transferring not that much data. We're doing. Actually, it will be interesting to see if I am going to batch these. So I'm going to take this query, and I'm going to put it here. So it could be that the batching thing is just really fast. So if I do this query is called query, and this query is also called query, I'm just going to rerun it, and now I'm going to batch these as well, just to make sure that the batching isn't messing with my my number of results. Because yeah, someone asked, the good way to do it would be really incremental. If I want to really benchmark the differences, I would send a request to the post first. I would then take the ID from it and use that ID to send a request to get my my other information. And in here, I'm getting similar numbers, but I'm getting half of the data. So it feels like, at least on my machine with K6, we get similar results. I tend to say it was different before, or it's different on my machine, but it's still the same machine. So that's a nice way to, I could have phrased it. But I hope the idea is clear. So we tested GraphQL. We saw huge differences whenever we send a request with GraphQL, where we define a subset of fields, as opposed to REST, where we would define all the fields. It gets a bit interesting when you try to do this batching, or maybe I should have done them in groups, where you would first send, in a REST world, send a request to a REST API. You would get an ID from your first request, and then you take that ID and put it in your second request in order to collect all the data you need. And with GraphQL, you would then be able to do it just like this. So theoretically, I should be able to get my data faster and also get way less data. In practice, it looked like we were able to do the same amount of requests, but yeah, we were able to do the same amount of requests, but we got half the data. So it's already an improvement. I'm wondering why we weren't able to do more requests, but that might be a question for later. So I hope you enjoyed this this sort of live demo. I always like to code in front of people, because then you can help me if I make a mistake. Otherwise, I'll just be stuck by my computer all day figuring out whatever went wrong. And there's much more you can do with GraphQL. So this is quite basic still, but I hope you learned how you could use load testing, maybe for GraphQL, but maybe also for REST APIs, because you're just able to put in any API there that's transferring data over HTTP. And I'm pretty sure case 6 has ways to test other transport protocols as well. So thank you. I hope you enjoyed, and let's stay in touch on Twitter or maybe here at the conference. Thank you.